Okay, guys, human endocrine system and homeostasis in humans. My name is Mr. Mpepu, and today's date 10 May 2024, Friday, and the time there 21 minutes past 1. With that being said, guys, Sanbonani, Dumelani, Afsheni, hello, welcome, guys. Today we'll be dealing with our osmoregulation and salt regulation, right? Let's dive in and study how our body use this function or use this system called negative feedback to control our water and salt balance in our body. Those two today, and then where we found them, which one will be this one completing, we'll be covering this water here and this salt here under our negative feedback, right? So you can see our negative feedback start here, so we can just do maybe two by day up until you understand everything, because they are there for you to understand. So today we'll do water and salt, right? The name of water regulation, we call it osmo regulation, from the name osmosis, right? Osmosis. And then another one, we'll have salt regulation, right? We are regulating sodium ions. So you'll see today, you'll learn at the end of today's lesson. You should be able to outline or to briefly outline what is happening when we say we are dealing or we are balancing our water level, and what is happening when we are saying that we are balancing our salt level. With that being said, guys, welcome to my class. We started at the 18th. Today marks the Friday, the end of our week 8. As you can see, even from what we have done, it can show or it proves that we were dedicated in our studies, guys. So then we are moving from here. We are entering negative feedback. From negative feedback, we are also going to do the disorders. After the disorders, we are also going to do the thermoregulation, right? This one here on its own. So you can see that we have many things broken down into small pieces, but outside it can look like a just small something, right? So thank you for being here, guys. Thank you for choosing me. Thank you. Hey, thank you for subscribing, guys. Thank you very much. If you haven't subscribed, guys, don't allow the train ushi, guys. So tsena go training we are still booking the seats, right? So welcome, guys, those who subscribed. Last time I checked, I didn't check at what number are we in our subscription, but guys, thank you. Thank you. Also shout out to what pumpkin, chocolate, what, right? This person here, the person, I'm not sure if it's a she or he, but the person commented hashtag shosholoza. So guys, we are shosholozing, guys. Noma kunzima. No. Yes, we are moving. Okay, so guys, welcome to my class. Welcome to my session, Learning Life Science with Mr. Mpepu. So today, guys, we'll be learning the example of our negative feedback, or the negative feedback when we are dealing with water and salt, right? You will see when we move on how we are planning this, as also you'll agree with me that some twitches has to be happen, or some changes has to be happen then there, so that we can cover everything that we are needed to cover before we write our mid examination, right? So thank you. We are still under endocrine system. Paper 1, you can also see, is 34 marks. So this 34 marks won't be like as hard or as piled as the previous one, which was 54, right? So here, even the information just have to be repeating, so that when you learn it and now understand it, right? This one is an understanding part. Like, we're now understanding that we have hypothalamus, we have pituitary gland, we have thyroid gland, we have islets, where in our pancreas, we have adrenal glands, we have ovary, we have testes, right? And the hormones that are being produced and the functions of these hormones. So today we'll be dealing with this hormone here, ADH, antidiuretic hormone, being stimulated by or being secreted by our pituitary gland. We explain this, right? And then we are also going to be dealing with our aldosterone there in our adrenal gland, right? This adrenal gland there at the top of our kidney, you know this, right? So today we'll be dealing with these two organs. Then these organs here, they are working together to maintain homeostasis. So whatever it's these glands and this gland they're doing, they are in a process of maintaining that constant internal environment, right? Regardless of or despite the changes that take place internally or externally, our body has to be automatically maintained. So this is in maintenance, right? So another thing from there, we move and say this process here, homeostasis, it is performing a mechanism called a negative mechanism, right? And this negative mechanism, it is triggered by a water level and our salt level. So you see, we are killing 3 stones with one bird here. So we are we are killing 3 birds with one stone, man. Ish. Ish. Aye. Okay, guys, let's move on. Thank you. Ish. But the condition within the cells depend on the conditions within the internal environment, the tissue fluid. We talked about this, right? So our cells there, we'll have our cells there, and then these cells will have our capillaries, and these capillaries will have the space there. So it will be maybe it will be a cell like this, or it will be the capillary like this, and this will be the cell, right? And then this capillary, you know that we have things that are being produced, then these things that are being produced, this cell of ours are recepting those things, right? So this is what is happening. So the fluid here has to be maintained. For an example, today we'll be talking about those two, right? Water. If the water is too much here, we are going to have a problem. Or when salt is too much here, we are going to have a problem. If, as you did, or as you know, the salt there, the salt ke la ya sodium chloride, right? Not letswai le batho ba buang ka le ke na le letswai ke na le letswai bana ke na le letswai. Gong gong. Okay, this salt here, the salt that we are referring to, sodium, is it like this? Sodium chloride, right? So you know that we have our, what do we call? We have our ions, right? So this sodium here is going to be broken from our chloride, and then we become sodium ion, right? So this ion here, you know, we understand, or at this moment we learn in grade 11 that in our kidneys, that's where filtration is happening, right? I agree. The blood will start from your brain. The blood will start from your heart, right? And then from your heart, there's the aorta. I did a sketch now. You'll see. Let's go to that sketch somewhere. Where's the sketch? I did this. Nowhere to be found. Yes. We'll use your imagination. I didn't save it, right? So as kids, so here's the thing. We have our glomerulus. We know that our blood has to travel up until our up until our kidneys, right, from our heart. So the blood will come from our lungs. Let's do a sketch nyana, revision nyana. Our heart will be coming from the lungs, right? So these lungs here, this will be like this. This will be the lungs. This will be our blood going back to the brain, right? Our blood coming to the lungs, and then our blood going back to our heart. So inside our heart is going to drink that blood. You know the chambers, the right and the left. Our blood is going to I had this. I was googling my thing. Okay, our blood is going now to go back to our heart, and then inside our heart is also going to pump out that blood via our aorta down to our kidneys. So inside our kidneys we have our left and our right. Yeah, this will be the right and this will be the left. You facing up, right? You facing me. Being you facing me like this, right? This one will be your left, this one will be your right. For now, if I say squeeze your right arm, you'll be squeezing this hand here, right? So you facing me. The artery will come, or the aorta will come from the heart down via the spinal cord up until it reaches this point here, and other one merge to the left, and the other one merge to the right, and then where to the left? To the kidneys, right? When it reaches the kidney, we have the artery. We call them kidney artery, or we call them what? Tubular artery, right? Renal, man. We call them renal artery. So this artery is going to enter our kidney, and then inside our kidney, we did this in grade 11, right? Inside our kidney, that's when we are going to zoom, and then something is going to happen. That artery is going to move up until it reach a glomerular, something like that, right? Make a glomerular, man, in Bowman capsule. You'll understand with me, you'll learn this with me. So here, let's learn this together. And then here we have our Bowman capsule. Bowman capsule, yeah, Bowman capsule. And then from Bowman capsule, that's where our artery, this artery here, we see it coming into our forming that glomerular there, right? So it will be like this. Forming this glomerular there, right? This glomerular, what is happening in this glomerular? Our blood there is being pumped in by our renal artery. This artery here, we are still talking about artery. So this artery is going to enter here via our afferent artery. So inside our Bosman capsule. I'm remembering this. You will bear with me, right? Unprepared speech. This one inside our Bosman capsule. This force here, this force of this blood here entering our Bosman capsule is going to force the components of this blood to be filtrated out. Something like this, right? So here we'll have more salt, we'll have more ammonia, we'll have all those things that we don't want, even water, right? So this side here, even the water is going to be pushed out. So when we push out these things here now enters our tubule, right? These things now enters our tubule, and then in our tubule now those things, they are moving. What do we call those things? We call them filtrates, right? It's a filtrate. We have a filter, as if like you have a filter and then you are safing so that the bigger rocks will stay up there, then the smaller one will go down there. That is how the safing is happening, right? Because this safe here release everything. So when this thing is released here, small nyana, this also will be the efferent arteriole. This efferent arteriole, they told us, or we learned, that is going to go down there. This is an efferent arteriole, still artery, right? It's still going to go down there and now merge, or this one is going to do like this, and then this one is going to do like ascending and descending, right? Ascending, descending colon, ascending loop of Henle, and then we see that this artery is going to form what we call our capillaries. You know that our capillaries, they are the you understand? They are the what? They are the those that they do what? They filter, right? They can absorb things. These capillaries of ours. They can absorb things, right? So they work like a, what we call, they work like a sponge, right? So what is happening, Uri? These filters here, they are going to enter our Couchman bowel via our our tubule, right? This will be the tube. So this tube here is going to, after that, this tube is going to end this one up until it become a urine. We learn this, right? So we learn this one is going to collect up until we urinate that urine there. But before this urine come here, there's something that is happening. These are efferent arteries. They are going to coil around our lobe of Henle, when for these filtrates now, when they are going down and when they are going up. What is going to happen, Mr. Mpepu, in that stage? In this stage, that's where now we are going to talk about the salt and the water balance, right? Now these arteries of ours, they are now just having, we can now just think they are just only the red blood cells. The water and everything, mostly of everything, is out, right? It is coming this side. They are meeting here. So when we meet here, now we'll be now that is the court. We decide, do we want water back, or do we want the water to go? Do we want, so these receptors here, they will be now deciding, do we want the water back, or do we want the salt, right? So where's the salt? Where's the water? The water is here. Where's the salt? Also the salt is here, right? So what is going to happen if we found here, this part here, I want you to concentrate on this part. This part here, this is where we detect if if we have more salt or we have no salt, right? So if we're not a little why, again, we are going to say, this guy is having salt. If we are having a salt, that salt is going to be recepted there. We are recepting that our blood is having more salt. So directly or proportionally, we are going to say that in this line here, we are going to have more salt, right? In these capillaries of ours, in these tubules of ours, we are going to have more salt, because the scale that is checking the salt here, it is going up to indicate that we are going to have more salt being absorbed there, or being filtrated there, right? That receptor, it's going to create an impulse and send that impulse to a very, very, very much thing that we talk about called aldosterone, right? Adrenaline on top of our kidney there. On top of our kidney, we have that, we will see that impulse there reaching that adrenal gland. This will be adrenal what? Adrenal gland, right? So when we reach that adrenal gland, the message, it's now going to activate that adrenaline. So whether the salt it was low, or whether the salt was big, or the salt level was higher, the message is going to be sent. This message is going to be sent here. So the message that is also constantly being sent, if here we have more salt, it means that the message that is coming here is going to be more. So what is going to happen with our adrenaline gland? Our adrenaline gland is going to stop secretion of aldosterone. Right, we are also going to talk about that hormone. So it will stop secretion of aldosterone. You know that this is a negative feedback, right? So we are negatively affected by what is happening here. That aldosterone is going to be stop being released. So no aldosterone that is going to be released. What is going to happen now? These openings here, again we have the openings here in our loops of Henle. These openings here, they are going to shut down because we have more salt. So let's shut down and allow the salt to do the what and be filtered outside. Let's shut down now. So if we have less salt in our body, if we have the salt level, it's going down, so we want that salt, right? So here's the thing. You know that when you have more salt in your body, what is going to happen at the tissue level? At the tissue level, let's say we have more salt. It means that this water that is here in this blood that is here, this liquid that is here, it's going to force water to move outside of a cell. So we don't want that water. We don't want that salt. We have enough salt in our system. Hence now we will allow each and every salt that passed here. It's going to be left and then come outside and then urinated. The control there will be that aldosterone. So the moment we say the aldosterone is going to be released, that's when we are saying that the salt in our body, it is depleting. It is going down. Right? It means that our salt level here is down. It means that now the water in this side, it is moving inside our cell. Our cells are becoming big. They are, do you understand? The water is moving from the lower concentration to a high concentration. We learn about this, right? So when our salt level, it is low, the message is going to be sent to adrenaline. So adrenaline, it is going to release that aldosterone. So that aldosterone is going to come here and be the judge here. Send the message here in our loop of Henle or in our distal tubules. We just said our distal tubules or our renal tubules. Renal tubules, the tube from here up until collective duct. So when now you can be specific, the collecting duct, the what, but we have those two, right? We can just say refer them as our renal tubule. Renal means kidney tubes, right? So that aldosterone is going to circulate there and open these valves and open that valves here. Again, we are saying yesterday, I even said that we have the valves and what. So aldosterone is going to open those valves, and what is going to happen? Our salt now is going to come out of those tubes. And then while that salt is coming out of that tube, our capillaries, they are reabsorbing that salt. Our capillaries can take everything. So our capillary will be reabsorbing that salt. And after that, we'll see that if efferent arteriole now becoming a vein. Again here, while it was cooling here, forming the capillary. The capillary, you understand that the capillary are the last part of our veins. So when our artery meet our vein, they form a capillary. Right, we form this joining. Hence we said we have vessels, or we call them blood vessels, right? The cables, or let's say we call blood vessels. Right, you can see that our blood vessels, they are branching. We have the aorta, branch something like this here, branch like this here, branch here, branch. So this is the last part of the blood, right, of the capillaries. In this side here, we are going to see being capillaries also coming down like this. So this idea will be the capillary, will be the hands. We used to say these are the hands joining there. This will be the oasis. It's like we are saying that is the oasis. That's where the right, the left, the what meet. Because after that artery, we now join a vein. When then the function of vein, the function is of vein. The vein is going to take that blood out of our vein and then up until here being our left vena cava. Left renal vein. Agree, here we have the left renal artery. So now we are going to see that left renal vein leaving there, joining our inferior vena cava there, and then this inferior vena cava sending blood to our heart. This will be your heart, right? And then somewhere in your heart, we also have our inferior vena cava, the blood that is coming from our head to our heart. Then this one is inferior, then with our heart. Then in your heart, this one will be the left, this one will be the left, and then this one here will be the right. So you can see the superior vena cava and the inferior vena cava, they are coming to your right side. Hence we said we have the right chamber and the left, the right arteriole, the ventricles, those chambers, right? We have two chambers this side, and we also have two chambers this side. The left hand side, it is bringing all the oxygenated blood, the one that is now is going to leave via aorta, and the one that is coming from our lungs. So our superior vena cava, they are going to pour our blood into our right side, and then also from the right side we are going to see the pulmonary arteries, and pulmonary veins sending that blood to our lungs. Then from there, pulmonary veins sending the blood back to our blood, so that the blood now can go to the aorta, to the head, and aorta to the legs. Up until now, the system now is rotating. Like I want you to understand that this is the system like this, right? Yesterday I even talked about the yin and the yang. Something you're not here. So you see this. Hey, this is the thing, right? This is the thing. Yeah. So this is the thing. When something is happening this side, there's the blood is revolving, right? And then where is the blood that now we say the blood is exchange in our capillaries? It means that in our capillaries, that's where now our cells now they are embodied by our capillaries. It means that if I have a cell like this cell now it has its own capillary doing something like this. So in this capillary, we have this water here. This now we say this is an internal environment. And then this internal environment, that is the environment that we are controlling. Right, so this blood here, you can see now this blood here, it is being sent to our heart, so that from our heart it's now going to be sent to be cleaned, and then from the to be cleaned, now it's going to be sent to our brain. Like in our brain, we don't want the chill, so the blood will start there in our heart, from our heart sent to a lung to be cleaned, right, so that it is going to change oxygen, carbon dioxide, and carry oxygen. So now being oxygenated is going to be sent to our kidney there, right? So in our kidney, it's being sent there to be filtrated, right, to remove the waste, with the salt, to remove that salt, to remove that water, or to add that water. That's where now we are measuring our constant measurement for the function of our brain, because this blood here now is going to be sent to our brain, right? So now we remove those salt, we remove those everything. Then from that, we send this blood now to our heart, right? So in our heart, we are going to have another blood being sent to our head, which will be the head here, right? The control center, right? So that blood, it will be from the kidney. Again, the kidney is going to be releasing the blood to inferior vena cava. The inferior vena cava is going to where's the structure of heart? Let me Google the structure of heart, right? Heart images. Yebo, this will be your heart, right? And then you can see this is the reference if you want to Google the Texas Heart Institution, but anyhow we can choose anyhow. We just that we come across this, and then let me zoom it for you. Then I will use arrows, right? If you can see my tapping, if you cannot see my pen, we can use arrows. You can start with these three arrows for going up, right? The left, and then the center, and the other one, right? As you can see, they are from the aorta. This renal, this artery, that's called an aorta, right? So you can see we are going back, we are reversing the moment, right? We are reversing this structure. I want us to have the same point for in case if you are not seeing my pen. This aorta is going to come down. You can see that the blood that is going to the aorta, it is at left ventricle. This is your left hand side. Agree when now you are facing me. You have this, you will be the screen. This screen will be you. This will be your left, right? To the right, you can see the pulmonary veins to the left and pulmonary veins right here to the right. You can see both of them, right? Pulmonary veins to the left welcoming the blood, and pulmonary veins to the right welcoming blood, right? So this blood here that is being welcomed by our pulmonary veins, it is entering to our left atrium, if I'm not mistaken, there, right? You can see that these pulmonary veins, the message that is being, or the blood that is being sent there, it is stored there in our left atrium, right? So that left atrium is the one that is there. They are taking the blood from the from the lungs, right? We are receiving the blood. Now that is the blood that we are receiving from the lungs, right? The lungs now being producing that blood. So yeah, let's see. Then from here, this blood is going to enter here, and then while it enters here, it's going to be sent via aorta, right? As you can see that the other one is being sent to the brain there. Then this oxygenated blood is going to be sent to the kidney. The other part is going to be sent to the kidney via our renal artery. I drew the space, the side, that thing, right? The renal artery taking the blood. So with that renal artery taking the blood there, the blood is going to come back clean now, right? And the blood is coming back clean from the waste that we were sending that for the waste, right? Also an oxygenated one. We are sending the blood that is oxygenated one, or the fresh blood, to be cleaned. Right now the blood is coming back cleaned. What is going to happen is going to come back via inferior vena cava. So when we enter the inferior vena cava, you can also see that we also have the blood that is coming from our brain. Right? This blood that is coming here, we said it is deoxygenated, isena oxygen, but it is clean. This inferior one is bringing the clean clean blood, and the superior vena cava here, we can say now, is bringing that blood that was being used up there in our brain, right? So the blood now comes and reach our right atrium, and then with our right atrium, the both blood is being sent straight down to our right ventricle. Right, you can see that right ventricle there. Then that right ventricle, that's when now that boom, that you listen when you bari telechapilu how that boom, it is this right ventricle and left ventricle pushing together. Again, they will be pushing simultaneously. So when we push, the other blood is going to be at the left. We can just imagine the other blood going to the left, the other one blood going to the right, meeting at a same meeting somewhere, right? So let's see. This one here is going to be pushed, and then also this one is going to be pushed. The right ventricle is going to be pushed our pulmonary artery. This pulmonary artery now going where, Mr. Pep? Going to our lungs. This artery, they are going to our lungs. You can see that artery there. This, you can see the other right artery there, leaving the right side, right? Your right side, your heart. I can you have two nipples. You have the right one here. That will be your artery going straight to your. So it means that it will be like this. So let's come here to our sketch. Let's move here. Let's move here. You can see the glands. We have the glands. I was fascinated by the heart, man. I'm fascinated by the heart. So if this is the heart, yeah, if you'll be leaning, you'll be reading there, right? But if you are also fascinated by the story of the heart, you can join with me. This will be the heart, ne? Let's do the color red. This here will be the heart. I guess they used to draw love, so we can draw that love here. This will be the heart, something like this, right? So we will have the blood. This will be your right. This will be your right hand side, and this one will be your left hand side facing me, right? This will be your eye, then this will be your nose, then this will be your mouth. Then when you can see even the time here, you just have to turn your back and face me. I'm operating you now. Even if you are learning this like this, operate a person, have a person in front of you for you to understand this, or what is happening with left and right, what. So, Mr. Mpep, we learned that we have two veins, and when you are saying that gubu is the pushing of these two, is the pushing of these two here, right? So they are pushing. So what is happening? Let's start with a kidney, right? Let's start with lungs. We have right artery to the lungs, right? We also have the left artery to the lungs, right? And then these lungs here, in these lungs we are going to clean that blood, right? In that lungs we are going to clean that blood. And how do we clean them? By capillaries. The capillaries, they are going to join. We did respiration. The capillaries are going to join, or they are going to cover that but they call them what? What do they call them? The broncholi, or those small thing in our in the smallest part of our lungs, right? You know that it's broccoli, it's a bronchias, and then ovar, something like that, somewhere there, right? So it's not abdominal, but it's going to make that capillaries. Then that capillaries is going now to take that clean blood, right? Clean blood back to the brain, back to the heart, man. That is the clean blood, right? Also this side, we are also going to transfer that blood, clean blood, back to the heart, right? So now inside the heart we have two blood. We have now inside the heart we have two blood, right? So let's move on. So we see that, or we learn that we also have another blood, right? This blood here, it is bringing the used, this we can say this is bringing the used what? They used blood from the skull, right? And then this is the superior vena cava, right? We also have another one bringing the used and the clean. Like you are saying, this is the clean, the green. The green, hence I'm using the color green, right? Is because this is the clean blood coming. You can see the blue and the green there coming from there to be cleaned here from these two part. This part again is the cleaning part. So this part here, they're cleaning the blood and then sending it back to our inferior vena cava, to our blood, right? So this one are going to join same thing in the same place, right? So inside your heart, you have now one blood that is clean, and we also have another blood that is rich in oxygen, right? So we have one that is, we removed carbon dioxide, and then after removing the that one that we remove the carbon dioxide, we see that the one that we remove the carbon dioxide, this one here, the one that we remove the carbon dioxide, let's use color, let's use another one. Now I'm fascinated by this. Let's talk about life science, guys. Then let's use these people. Agree here, we say that this blood here that came with oxygenated blood, right? That was rich in oxygen. It enters our heart there. And then from our heart, this will be the third here. And then from our heart, we see that that blood now is being sent to your brain, right? This will be another part sending that brain to your. Here we are talking about those cortic artery, those jugular vein. You know, we have a jugular, the one that will slice your throat. That is the jugular vein, right? The vein that is taking the blood. It's the vein taking the blood from the heart to the lungs, right? From the brain to the superior vena cava there. So let's talk the story here. This one that was oxygenated here, it is now coming to our brain, to our heart, and then we can see it's being sent to our brain. Why is it being sent there, Mr. Mpepu? You can say it is sent there to transport that oxygen. We have the station there. This is the station, this is the commander, right? We are supplying that oxygen, right? But this oxygen that we are supplying there, we are supplying it to also bring something that is going to bring it back with our superior vena cava there. So this oxygen, this will be the change in this capillaries there, right? There will be the change. This one that is bringing oxygen to be given oxygen. After it will give oxygen, it will trade, right? You trade oxygen with hormones. Let's do like that. You trade oxygen with ADH. Thank you. Right? We are trading this ADH there, right? From our pituitary gland. And they say this ADH is from pituitary gland. So also another thing, we also have this one here will also bringing water, right? This one will also bringing oxygen. This one will also bringing water, because that water is hydrogen plus oxygen, right? So we are going to take oxygen there. We are going to take that oxygen, mix it with hydrogen, mix it with oxygen, send it up there. So this trade here, they are going to buy something there. They are going to buy those neurons. They are going to buy those hormones, bo ADH, bo pituitary gland, bo bo follicle stimulating hormone, bo luteinizing hormone, bo growth hormone, bo what, right? So here's the thing, what is happening? It means that this blood is going to come here, hit the hypothalamus. After hitting the hypothalamus, now we see that blood now coming back, something like this, right? So this blood here now is coming back deoxygenated. This is how now we say this blood here, it's coming deoxygenated, but you can see it's our green blood. It's having all those things that we need from the upper head, from the north here, from the creator, right? From the crater, from the cranum, right? And then it's bringing back, or it's bringing down all that juices, sharp, all the things that have to be sent to our body so that my body will function well, right? This blood here now, it's coming, enters our brain, enters our enters our, what do we call, enters our heart there, right? This blood here is entering our heart. You can see another blood now, right? That blood is entering right ventricle, right? From right ventricle, it's also going to join with this clean blood here. This will be clean, right? And then this one here, it will be clean from what? Oxygen, wrong. The oxygen will not be here, right? The oxygen will be depleted. And then the also that is coming here, the oxygen is depleted. So we traded something. In our adrenaline, we traded in our kidney, we traded this oxygen with something. In our brain, we traded this oxygen with something. So now we are bringing whatever we have traded back to our heart, right? So now you can see that this blood here is going up with oxygen. Now as an athlete, we can say I can give change trade and barter. Go file oxygen, mfe adrenaline. Yeah, ko file oxygen, mfe salt. Ko file adrenaline, when I make sure or the rest show uri, ko file oxygen, when I make sure uri my water content di sharp there. Are we clear? Yes. So now we can see that the blood here, let's do another blood. We can see that the blood here is coming into our brain, to our heart, right? Then from our heart, we see that from our inferior, what we call right ventricle, what ventricle. Now we're going to see that blood moving out of that pulmonary arteries. You can see these pulmonary arteries now sending this blood to the lungs and all over, right? So now this blood of ours, let's go to our heart now. So now you can see that these pulmonary arteries, they are now having, or they are now sending those hormones to our lungs, right? So we can think, or we can predict that in our lungs, from there, that hormones, they are going to come back from our lungs, right? With new oxygen, and then that hormones now still going to, yeah. Thank you. And then this blood here is going to be here, mixing this blood here, and then this process is going to repeat itself. This blood here, now this blood here will go up with the hormones, right? With oxygen and hormones, carrying also those hormones. That the trade is also going to go up. Trade something with something here, coming, bring it back. Trade something here, bring it back. So if this blood here is bringing more water, if this blood here in our renal artery, it is bringing more water, the water level is more, what is going to happen? Our brain here, it's from our brain, right? Our brain here, it has to produce something, it has to stop the production of ADH, because we have more water. When we have more water in our blood, it's going to shut down the ADH. When we have less water in our blood, it's going to turn on ADH. So I want you to understand this. This ADH that is being released by our blood here, it's released because of this blood that they are trading oxygen. So it means that when you will arrive to your head and give oxygen to your head, and then you tell the head to stop producing ADH, and then the head stop producing ADH, you are paying. It's not just happening. You are paying, that you are using that oxygen. That oxygen is currency. Ya mobile. And then from there we also have glucose, the glucose and everything and water and what. So if your water is fine, it means that here will be closing. But if your water drops, right? So now you'll have to learn what is the significance, or why is it necessary for us to maintain this water when the water is dropping? Because our cells, they need water. Everywhere things are being sent by water, right? Water is sending everything. It's just that what we call oxygen is being sent by our what we call our hemoglobin. But that blood of ours, it has water, and that oxygen, right, in that water, that oxygen in that water is a very much important one, because that one is going to form that ADH not to be produced. So we stop the production. So tomorrow the message will come, right? The impulse will come. right? When the impulse comes, when this blood here is coming here saying that, oh no, we have our oxygen over water. So we see that if our water is depleting low, we have to trigger our ADH production. So if water is low, we are going to say, okay, give us oxygen. We now will give you a ADH. Then that will be ADH over water. Skiscape. Rechange. Richa oxygen rofa ADH. And then that scape now, siya nyuluwa. Kiscape, siya nyuluwa. Sitla so. Coming down, bringing that ADH to your heart. Then from your heart, your heart, your water, your ADH now is going to be sent to your lungs. That one will be ADH, right? Then from the lungs, your ADH is going to be oxygen, right? Okay, now here we have oxygen over water. This side now you will have that ADH now having that oxygen. Then these now use as another transport to now shift to take our blood back to our heart oxygenated and then leave it with our aorta. That this aorta now is going to come down again. Aorta, and then this will be artery. Then this artery now is going to be coming down to our vein here, our kidneys there. So this artery now coming down to our kidney there, it's going to have our ADH over oxygen. It's going to trade. Right? What is it going to trade? It's going to open here. It's going to force that actually here we have our nephron. You know that we did nephron, right? So that ADH in that tubules of ours that they are going to spit that urine out. We are going to now to trade that opening there with our ADH. We'll say that we're now with oxygen and ADH, we're now open this, and then that thing is going to open, or those mbobo there, they are going to happen. And then while they are opening, because they are permeable to water, because they are only there for water, hence we find that any other substances they can pass, right? That water, because you can know that even the substance of water is very much liquidy compared to others, right? So that viscosity, so that water is going to pass out. And then while that water is passing out, what is going to happen? Our now clean blood going back is going to coming back with our enough water. So it's going to come back with our enough water, and now lacking oxygen. Again, it's deoxygenated. So now it's only water there. Oxygen it's really carbon dioxide, using a new shape here called carbon dioxide. Then this carbon dioxide, you know, when we reach our lungs, is going to be released, right? You did a oxygen exchange. You did a gaseous exchange in grade 11. What is happening here, CO2 is being released, and we replace our blood with this is the station that is happening. We are removing CO2, we add oxygen. Remove CO2, we add oxygen. So the blood that is coming to our lungs, they are in this shape. They are having water, or constant water and constant salt, right? More water and best salt. That is the combination that has to be moving. So this best water, best salt is going to our heart, and then inside our heart, it's going to be given oxygen. It's going to our heart. Inside our heart, it's going to our lungs. In our lungs, it's going to be given oxygen. That now will be water. That now will be that water with oxygen. And this water with oxygen is going to be sent to our brain. Inside our brain, our hypothalamus is going to sense, right, we have enough water, and then it means that our oxygen is coming fine, right? So for our oxygen to be transported like this, it means that our water is fine, and then that water release that oxygen there, and then come back alone if everything is fine. So if homeostasis is meant, is meant, this one is be like this. We'll just take that oxygen and leave that water to pass, right? And then that water will now go to our heart. From our heart, our lungs, to our lungs, we add that water into that oxygen. We turn that, we send that water with that oxygen to our kidneys. When we reach our kidney, because now the water that is coming here, it is oxygen and water. This oxygen is not being placed by ADH. There's no ADH. The ship was sent free. So the ship is coming with only oxygen. That now we can say, hi, let's close this valve here. Let's keep them closed. There's no ADH. They cannot buy, they cannot sell for that, right? So that ADH there is going to be, so that permeability or those tubules there, they are going to be closed, and that water now will start now to flow. Same as dams, how they build this dam. Agree, you build the dam from the upper side like this. This will be the water coming out to the river here, and then this river will close it here, and then now we end up with a dam. So now we decide when are we opening the dam or when are we closing the dam. If we see that the water downside it's less, we open the dam. If we feel that the water downside it's more, we close the dam. Right? It's just that now they are no longer closing, they are no longer opening these dams. Go home and check every place that we have dams after river. And when inside the river we have a dam, they are closed, and it looks like each and every river in a dam, and they are closed, those dams. So it means that us down there or us here, we are being now what do we call, we are being now compromised. That's another show, our farming, our what. Hence now we can open these dams and let the flow of let the real currency of the world do its thing. I agree, this world, this, before we can build those dams, this world was doing everything, was doing fine. We have the higher lands, we have the lower lands, so everything like that. So guys, thank you for being here, thank you for choosing me. My name is Mr. Mpepu. We are done with our water regulation, our osmoregulation. Before I can speak things that you see, revision. Now we are doing, thank you for being here guys, Friday, Saturday, next week, tomorrow, next week we'll be dealing glucose. Now you know what is happening with our water and our salt. Then our salt there, yes, let's talk about it. We can have these 2 seconds. We have our control center, which will up our head, right? Then we have the effector, then we have the homeostasis. So if that water is going down, that message is going to be recepted, and the message is going to be sent to our brain, and our brain is going to send that message to our our adrenaline. This adrenaline is going to produce our aldosterone. Aldosterone is going to bring up this balance here, and then everything is fine. So if the balance is fine, it means that the receptors are not going to send the message for that aldosterone to be produced. So the aldosterone will just be there. That is another currency that we'll talk about it, right? So we move on. We did this. I told you that we are going to learn 6 of them. Today we did water and salt, right? So to next week you can see we are going to do thyroxine, glucose, carbon dioxide, and temperature. This one here, we are going to use a specific machine or a specific organ that is being built to regulate that temperature. Specifically, it is built for that, right? It is therefore regulating that temperature mostly, and it's stopping everything, right? So we can see we did the water there. The water there, you can see we were we were going to do with the lungs. Then the next week we are going to deal the thermal regulation. We are going now to be talking about the skin, what is happening, right? The salt, the kidneys there inside those tubules, so those renal tubules, right? That's where we see the salt being removed, and then the capillaries reabsorb that salt back to our system, right? So now we can move on, Mr. Pip. You see, osmoregulation. But the maintenance of water balance is very important to ensure that the body metabolism continues. The homeostatic control of water and salt level in blood and tissue fluid is carried out in a negative feedback system. So the system is called negative feedback. We talked about this. This system is called osmoregulation. We are regulating what? Osmosis, water, right? In our blood. That is the water in our blood. So this will be the blood, or this will be the scale, right? This will be the scale here. This will be the scale. This will be north. This will be south, right? So if we are saying south, we are decreasing. If we are going north, we are increasing. We have to maintain that static there. So yes, what is happening? We have the normal water level in blood. This will be the normal, right? This will be our Shosholoza train heading this side, heading east, right? So when we move further north, we have to bring it down. When we move further south, South Africa, we have to bring it down, right? So let's see in this train of ours, the water level decrease. The water level decrease. What is going to happen? We need ADH. The moment I said we have low water, it means that we are going south. Someone has to come up with ADH. Water, low water, I need ADH. Hence we see that now that ADH is going to be produced where? In our pituitary gland. Then from our pituitary gland, that ADH, we know where the ADH is going to do its job, right? It's going to do it where? In our tubules there. right? Convoluted, distal convoluted tubules, and we call them distal convoluted tubule and the collective duct, right? Then they are going to do them what? Permeable, right? In a collecting duct. Yeah, they say the collecting duct, the last one that is falling, and this one, the distal tubule, the one that is going that side. So we know that now we are going to release we are here, the water is more, the water is less, we are going to release that ADH. After releasing that ADH, we are going to reabsorb that water back to our system, or more water reabsorbed into the blood, right? It means that we'll inject more water. Actually, we can see that our ship is going south, or our, yeah, this can be, it can work better is if it's a ship, right? Not a train. This can be the ship, right? The cruising ship, they call them ship. Is it a ship? A cruise, a ship. Is it a ship? King that thing. A rocket, a spaceship. Yeah, we call them a spaceship. A ship, a ngwana. We call it ngwana, a ship, lamb. So in this spaceship of ours, if we are having more water, we'll need to inject that water back, right? Then for injecting of that water, we see it by reabsorbing that water back, being controlled by our ADH, right? So let's say our things are moving fine. We are now at the coast. Coast number 155, check. Those were the south. What is everything? Is everything fine there? Then we find that no, the water, it is increasing. So it means that we are going north, right? Hey, Mr. Head. Hey, the water station 1, commander. The water is increasing. So it's increasing here. This is where the water now is increasing. Hey, we have more water. Station number 55, commander, we send the message to our pituitary gland. Check number 11. Stop releasing ADH. Because the more ADH, the more the water is going to come in. Then you can see that the pituitary gland stop secreting that ADH, right? While we are stopping secreting that ADH, we are going to do the same thing. Here we permitted the water. Here we are now going to make that place to be non-permeable. So we are going to close these valves here. So he said the permeability of collecting duct and distal convoluted tubule decreases. So we are closing this one. We are closing these valves here. We are closing them. Then after that, our very less water absorbed into the blood. So the water here is going to be not allowed to come back to the blood. So hence now we keep that coast, right? And then now we can say the left wing. I can it's a space here. We are upgrading today. From now on, we are no longer in a train. Hi, we are upgrading now. Now we are flying. This will be the left wing. This will be the right wing. Right, the north, then the south. Then when we are facing where? That side. Right? Then we are saying commander number one. And then the commander number 1, the person is here. Right? Commander number one. The water is decreasing. Where? He will be saying this. Then we have to send the message. In our body now, we have to send what? The impulses and then the hormones. Right? So that's how we send these messages in our body. So we are done with our salt. Let's move on. If you want to use that scenario, you can use that scenario of a plane. Then if you are going north, you see that the more it's going north, is the more the water inside it is decreasing. It's a flating, right? You can flate. This is the balloon. You can also say this is the balloon. You know, in a balloon, if this is the balloon like this, the more you add water, right, water level decreases. The more you release water here, it means that our balloon is going to be going up. Our balloon is going to go up. So for us now to bring back the balloon to a certain place, our water that is going out has to come back. Then while we are filling that water up, and then you can see while the water is increasing, it means the water is increasing, our balloon is going to be heavy and the balloon is going to move down. Then for us to bring back this balloon, we have to release that water. I hope you understand this. I hope you understand this scenario. We spent almost 1 hour trying to bring up this homeostasis. You have to know this. I will cry. I will fight for you to know this. Not to creme. not creme. You have to find, you have to know this, know it by head, by urobates when you are sleeping. For when when you feel like now I want to urinate, no, that a complete system happened. And for me to urinate now, it means that my ADH is not even being produced. But if I see me not urinating, I know that hey, maybe my brain problem, maybe it's producing more ADH here. Or if maybe I can say I drink water, but the urine that I release is round, it's brown, it's red. It's like a chlorine plant. So I can now conclude, hey, you understand? So this one is the water. So now let's go to the salt and see, Mr. People, if we can apply the same thing, right? You can see there's the notes there. The process is called osmoregulation. When we have the below water, we call you a dehydration. When you have above water, we call you a overhydrating. So this one can kill you, and this one can also kill you. You are overhydrating, you are dehydrating. So you have to keep the balance. You have to keep the homeostasis home. Dula high. Stay at home. That is the balance that you have to keep. Don't go anywhere. Dula high. So, but a decreased water, the water is going down. And then this side, the increased water, the water is going up. So you can see, we call it dehydration, over dehydration. But the excess hot, maybe this one can be caused by hotness, temperature, or the losing of water, right? You can lose water by hot or by exercising, increased sweating, or decreased water intake, right? So these can cause or can result in our water level becoming low, right? So you know, when you get the report that your water level is coming low, you need more ADH. So here the impulse are sent to the pituitary gland, and antidiuretic hormone, it is released, right? So here this side, because we are fine, this one cooler environment, and then no sweating, no excess income, so there's no excess water. So this one is going to cancel that production of ADH, right? Then the water levels in our blood and tissue are high, and this dictates the water. I didn't say in hypothalamus, right? I get the water. You know that it has to go to hypothalamus for the water check. That is the water check. We are checking them in hypothalamus in a process, or in a receptors called Osmo receptors. Osmo from water. So these are the water receptors. They are there waiting to check water. When the water passes, hence we give you that sound in hospital. Then means that system here how we off. So it means that your system now is fine. So it's counting those receptors that they are counting the water, right? 50 pass sharp, 50 pass sharp, 70 no, over. Then when you say over, we are going to cancel here. Then low, we are going to activate this side. So from there, the collecting duct or the tubulars, they are going to, here we can see if we have more ADH, we are going to have this one, the collecting duct increases, right? The absorption, and then the permeability node becomes less. So here we are closing those doors, here we are opening them, right? And then with this one will be closing them this side. So more water is reabsorbed and passed into the blood, and then less water, it is reabsorbed into the blood. So the water that is coming in is going not to be allowed. Here the water will be allowed to come in. So here will be understand. Then the urine is going to come out this side, but the blood becomes more dilute, and concentration urine is secreted. So here the urine will be you go to the urinate, and then you just remove 2 drops. This one will be 2 drops, but this side here will be because of that water that we let pass, right? So this one, the urine will be this side, and then the urine will be this side, man. Then this side is this inside here, it is our blood condition, right? This side here is our blood condition. Then after that, we say that our blood is fine, by water levels in our blood and tissue fluid return to normal, and homeostasis is reached, right? So this will be the check. Then this side here will have more urine, and then this side here will have small drop like this. So you see, rain, for us to have more rain, it means that our inside there, the water is fine, right? So you can see here, when you urinate those small, it means that inside there we wanted water. But if you urinate more water, that is the message to you that inside there they have clean water. So when if you see urinating something like this, you'll have to drink water, because your body now is telling you that we have more water. But if you are seeing that your urinating is big, you are fine when, right? So let's move. Hence, when you are exercising, you don't urinate. We are still going to talk about this. Hence, when you are running, you don't find people, hey, stop, let me urinate. Right? So let's move on to our salt. We are done for today. Our time is up. But negative feedback in the regulation of salt concentration, and then the osmotic pressure. We talk about osmotic pressure. That thing that actually we have a capillaries and we have our cell here. So this cell here, this will be the solutes. This will be the salt, the glucose, the potassium, the what, right? This one will be the cell. Note that remove that place here, glomerula. Glomerulate something else. This one is a cell. You know it's a cell having a nucleus, having a cytoplasm. So this water here, this will be the capillaries, right? So this water here, this fluid here, we have to maintain this osmotic pressure. We talk about this osmotic pressure. So if we have more salt, the water is going to move from high concentration to the low. If we have less salt, the water is going to move in. So we have to keep this constant. Right, so for the best way to keep this constant is to control our water concentration, our salt concentration. We also have our glucose regulation, right? So we are also going to learn about our glucose regulation. Now we are learning about this salt regulation. So you can see that this salt here, you can see that the osmotic pressure in the blood and tissue fluids is affected by the presence of solutes. These solutes, you know what is a solute from your chemistry. These are the substance that dissolve to a solvent, right? So here we'll talk about the salt and sugar like glucose. Like sugar is a glucose. So tomorrow we are also going to talk about this glucose regulation and also this salt regulation, because this one they are going to dissolve into that water that we are transporting up there. So if that water is coming with more salt, we also have to do something. If that water that is coming with more sugar, we also have to do something. These are like the pollutants, but they are needed in our body so that things can be moved from one place to another, right? So we can keep that scale also into the balance, that homeostasis into that balance. We need to balance that salt. When we have more salt, it's a problem. When we have less salt, you have a problem. When you have no salt, you have a problem. So you have to have salt, but enough, right? So let's get in this spaceship and drive it and see how we are going to drive it. But the glucose and the salt, as you can see, the glucose and the salt make up the solutes, right? So this is a sugar. It's like same thing. The sugar and the salt makes up a solute. You add sugar inside the water, the sugar is going to dissolve. That is the solute in a solvent, right? So you understand that. So sodium ions and potassium are salt that are regulated in a negative feedback. So in this negative feedback, we are regulating sodium and potassium. Here's the thing. Salt is not sodium. Salt is a sodium ion made out of sodium and iron. So it means that my body has to break down that salt and acquire that sodium. And then that sodium now has to be sent to the blood, has to be absorbed to the blood. That in that sodium being in my blood, that's now determine whether I will have to urinate that sodium or I'll have to keep it. You got that? You have to eat your sodium ion. Your body is going to break this and then absorb this sodium ion, right? Then when it absorbs this sodium ion is going to be in our blood. So this sodium ion in our blood is the one that we are going to regulate whether we want to urinate it or we want to reabsorb it. Where? In our kidneys out down there, right? These water and kidneys, they are controlled there in our kidneys, right? And then the glucose, we send the blood to the liver. Glucose is the liver and is the our muscles, where we send thyroxine, where we send glycogen and glucagon. We're still going to talk about that. So this scale here, but we have to keep the sodium and the potassium regulated, right? So it means that this side here, we can have sodium like this, or we can have potassium like this, right? Potassium is K plus. So here's the thing, it's not like sodium this side, salt this side. No, sodium says, yeah, you understand. So these two here, they work together at this side. So if we see them this side, we're also going to see them this side. This side will also have this and this, right? So this one plays hand in hand. When we see, okay, let's move there. Let me explain this for a second. You see that the sodium there it was this will be our let's take this as a glomerular, right? So if this is a glomerular, this will be our glomerular there. So this one will be releasing the sodium ion, right? So for sodium ion to enter our distal convoluted tubule, we need potassium this side, right? So you'll understand that when we have potassium, when we have this potassium, it will come and it will reach here. Will this potassium passing here, it will be now bringing that sodium ion with it. It will now bringing that sodium ion with it. So this one is a chain, they work together. So here's the thing, when you have more sugar, when you have more salt, it means that your sodium ion is here in the blood. It is not passing to your distal tubule. Why is it not passing? It because you are shooting with a potassium ion. You need potassium. You need to eat bananas. You need avocados. So that these avocados, they will be the carrier of that salt, so that we can pass with that sodium to the next part. Hence, we need that potassium ion, right? Then while that potassium ion is this side, now is our body to navigate, or to tell our body whether we want to take our salt outside or we want to let it run with our potassium. And we don't know, or we have in learned where they are saying that the potassium is also going to be reabsorbed. I'm not sure, right? But this one is salt. Now I'm just trying to make you understand that we have a salt and we have potassium. And we have the salt and we have sodium. The sodium is not salt, right? The sodium ion is not salt. Hence, we can use this interchangeably, because you eating salt, you are increasing the sodium of yours. Cation and anion, right? You know those. So this is what is happening. It's not like the sodium ion have to be that side, the potassium ion has to be that side. No, we are concentrating on sodium alone. So if you have more sodium, it means that your more salt will be passing to your tubules. And then in that tubules, we'll have now to send a message called aldosterone to open or close. Okay, that's where we are opening or closing. In this one, we are opening or closing. So let's see. But our salt regulated, but figure show this one, right? So let's see, this is our scape, this is our ship. Then in our ship, let's see, we have our north, and then we have our south, right? So, but the salt level in the blood decreases.
Madam Abono, W8 business video.
Okay, guys, someone is looking for me. We're done. We'll finish tomorrow, and then let's do this 2 minutes. Well, the time is already done, right? So our salt level, it is decreasing, right? If our salt level is decreasing, it means that our ship there is going north, right? So we will need to secrete that aldosterone, but the adrenal gland secrete more aldosterone. For this aldosterone, so that it can come and open where reabsorption of sodium ion increases, so that it can come and open there, right? Open that permeability. Then after opening that permeability, that's where we see that sodium ion being allowed back to our ship like this, right? That's where we allow it back to our ship, so that it can bring the ship down. It means that we're going north, so now let's bring it down, Nyana. Let's bring it down, bring it down. We are adding that sodium. Bring it down, that now we are looking. Correct, right? So let's do another example, another way around. What if now here we'll say open, right? Here I want to use that word open, because this aldosterone is going to open or it's going to make permeable, right? Permeable. They say this one is a permeable. They are opening that channels, or they are opening those gates, so that the sodium ions can now move from the outside to the inside, right? So let's see, when maybe we are going down, we are adding, right? So we know that this is the balloon. We'll use our balloon again here. With our balloon, you are increasing the salt, right? It means that you are increasing the salt. Our ship is going to go down, right? It's going to go down. For the ship is going down, we have to bring it up. Bring the ship up. Maintain the homeostasis. Maintain homeostasis, Mr. People. What you're going to do, you are going to send your message to the adrenaline gland here. Is going to send the message to stop releasing those aldosterone, right? Or release less, because we are fine now. We don't want to overflow our chamber. So our aldosterone is going to be stop releasing, while with this stop releasing is going to affect, it's going to close down those chambers there. It's going to close down those chambers there, those openings there. Then while we are closing them down, the reabsorption of ions into the blood is going to decrease, and then the level of our blood decreases to normal. So now closing it, our ship will now be moving up until we reach the place. Then we are saying that we are fine. Then so we are done, guys. Note the two, and then you can see the salt one, very much a not complicated one, because we are building, right? Then we almost, that is control of salt. You can see now the salt is going down here, the salt is going up, right? Then you can see, but this will be your blood, this will be your blood, right? So you can see the low salt level of blood and tissue fluid is going down, doesn't have a name. You can see that one, it's called a osmoregulation, right? So this one does not have a salt regulation or sodium regulation. We just said it's a salt level in the blood tissue. It is increasing, right? When we see the level is going up, when we see when we see the scale or the gauge, again we have the pilots, when we see the line here moving to the north side, we conclude that our salt level, it is what? It is increasing. Again we will have the dashboard. We have the dashboard, that thing, right? So in the dashboard, when you see that line going to the north, or even this thing, again, this one will be north and this one will be south. So if you see the gauge here going north, we say that, we conclude that our salt in the salt gauge, right? Again, we have the water gauge there. Then this salt gauge will be where? They will be in our kidney, the receptors. We want this gauge this gauge, we call them receptor cells. This one, they are connected to a kidney, or they are stored in a kidney. If you are saying, hey, get inside your body, Mr. Paper, do a mechanical checkup, I'm also going to the kidney and see this gauge. And if to the kidney I see that my gauge, my salt gauge, it is now to the north, it means that I have more salt. The salt level, it is increasing. So I'll have to do what? This one is going to stop the releasing of aldosterone, because when it's going like that, it means that our salt in our body is increasing. I'll have to cut off the production of this salt so that our line will come back. So hence we cut the aldosterone there, right? We cut it. So if we see that our thing is going to the south, it's going south like this now, it's going south here in our scale, right? It's going south. We conclude that we have less salt level, or the salt level, it is decreasing. Where? In our receptor cells. So these receptor cells in the kidney, they are going to detect that change, right? Send it into adrenaline. Actually, we have a kidney here, then we have adrenaline. This one is sent to the adrenaline. Then this one, they're going to send to the adrenaline. Then the adrenaline is going to release that aldosterone, because we have less salt, right? That aldosterone, the adrenal gland in the kidney, they secrete aldosterone. Then the aldosterone is going to stimulate the reabsorption of sodium ion from the filtrate and back into the blood. So this aldosterone is going to open here, then so that the salt will come back to the blood. Again, this one is a blood, this one is a blood, both of them, right? So the salt can come back. But if we have much here, we are not going to expel that salt. We are only just going to close. So the salt is not going to be allowed in. Here the salt will be allowed in, right? So at the end of this, but less sodium is excreted in the urine. So this side in the urine, we are going to have small like this, small salt, right? So here we'll have fine blood. So yes, they can see the salt concentration of the blood and the tissue returns to normal, and the homeostasis is maintained, right? So even this side, if we don't allow the salt to come, these are the doors. You know, the door, you don't expel people, you allow them to come. This is the blood. The blood does not expel things. Just the blood takes. The blood takes. So here we are going to not allow the sodium ion to come in, and then more sodium ion is secreted in the urine. So this side here, we are going to see that urine having more concentration of sodium. So if I come with the scale, or if I can come with something to test your urine and find that in your urine you have high number of sodium, it means that your body is using sodium sharp, right? Because you can see that your body is not producing that aldosterone. Another thing, I can come and test the presence of aldosterone. If you don't have aldosterone, I can now conclude that your sodium is fine, hence you are urinating more sodium. But if you are urinating less sodium, I can come and conclude that the person, because it's releasing less sodium, it means that the blood can be suffering from sodium deficiency. So this sodium here, it means that when you are more doing that, it means that when you have to eat sodium, when you eat sodium here, it's going to add sodium there. When you eat sodium here, it's going to add sodium there. So that will be the part of the brain now to decide: do we keep this sodium, or do we add? If this blood is going to come, yeah, something like that. So we are done, guys. We did an example of this. So we did an example of this. Here the salt is coming up, right? The salt level is going up. So for you to I get the level, the side is this, right? This is the side inside. So aldosterone is going to stop releasing aldosterone. The adrenaline is going to stop the releasing of aldosterone. So we'll have to close this side. This blood is going to pass here, and then this side. The water is going to pass here, then this side. So we want this water to pass. You don't want anything to do with it. Let it pass and leave. But in this one, when this water passing like this, when this water is flowing, passing like this, we still want that sodium ion that is there back to our blood. So this water will be flowing like this. This water will be flowing like this. So when this water is flowing, we are adding our sodium ion here. So when this water, this one will be the blood. So this water running like this here will be now catching. From there we'll be determining if we have more salt, we'll let it go, run. You know what we're talking about. Our neuron, our nephron, right? So that was it from me. You heard the call I was being called. So guys, let's meet again to next week. Next week we'll be doing another ones. We have 5 of them, right? We only understand 2 today. We understand this. And if I have more salt in my blood, if I have more salt, the salt level is increasing in my blood, I will need less aldosterone, right? So if I have less salt in my blood, I will need aldosterone so that the salt will come back. We will welcome back the salt. So if you have more water in your blood, what is going to happen? If you have more water in your blood, your ADH is not going to be produced. That water, that side is going to be left and go outside. You have more when we don't need it. You have more. So even this side, when you have more salt, we are fine when. So that sodium, if it's more in your side, it's fine. But if that sodium is going down, so it means that here we can bring this, if this sodium is going down and then we close this one, it's going to form this, it's going to cause this sodium in our brain to also deplete. In our blood, right? It's also going to cause this blood now to also deplete because we are not adding any salt. So this salt will be sent to the different parts of the brain, different parts of the body, waking or attaching with water, sending it in this blood, right? But this blood is going to be depleted with sodium ion. So this blood alternatively is going to turn like this, capillaries here. So when this blood comes this side like this, it will be having less salt. So now we'll come and add that aldosterone so that that opening will open and we welcome more salt. Now we take that salt nyan so that that salt will now come and make a round, come this side, we leave this side. Then it's going to be used here. After using here, coming this side, you understand? That is the cycle, a yin and yang. Thank you for being here. Thank you for choosing me. My name is Mr. Mpepu. Until we meet again next week. Today it's Friday. Guys, but that was it from me. Until we meet again next week, guys. Thank you for being here. Thank you for choosing me. If you know better, you will do better. That was it from Mr. Mpepu. Let's meet again. Those who haven't subscribed, get subscribed. Yo, we are done, guys. Today marks a milestone. So let's move on with this imaginary or this creative thinking of ours. Right now we can creative, or we can take a plane and now see that this plane is like this. So it means that if I'm going south, it's going like this. If I'm going north, it's going like this. If I'm going south, then the compass, right? So let's go and do this together. My name is Mr. Mpepu, African transcribers, transcribing those messages that are being embedded deep in our blood and in our DNA. Why do we have to study outside if I don't know inside? Why do I have to be more concerned of how the cow is working if I don't know myself? How would I be much concerned of creating a robot that can do something like me while I don't know what is happening with myself. So let me first found the inner you, understand what is happening with your body. That's when you can now go outside and study other things. First things, I and I. My name is Mr. Mpepo. Until we meet again. Thank you, thank you, thank you. Peace. Kgotsong a e be le lena molalo ka bana batho bote kurula kube nani kurula kuba na n'wina kuthula kube nani until we meet again Monday. Saturday, have a great weekend. From Ricky. If you don't hear from me Monday, no, we'll meet at the other side. Thank you guys.